covariance. For the correlation, it's the degree of relationship between two variables, and the variables can be positively correlated or negatively or no correlation.
Okay. So, what we are trying to mean is basically that degree, it's the strength. Okay. So, correlation basically shows, gives us the strength of the relationship. Okay. Like, for example, if we are one, that is, we have a correlation of that is of one, then it means that is our correlation, or yes, our strength of relationship, it's like 100%. Okay. Yeah. And as we had said, that is correlation coefficient. Correlation coefficient, it is runs between one, negative one, and what, and one. So we have what? Let me just illustrate that. Let me illustrate that. So I'm going to illustrate this with what? With a number line. We have zero, okay, and we have what? We have one, okay, and we have negative what? Negative one, okay. So correlation runs between here and what? And here. Correlation of one, we usually call it perfect. We usually term it as what? Perfect, perfect, positive correlation. Okay. Then for the negative, we usually call it that is a perfect negative correlation. Okay. We can also maybe try to divide the interval. Let's say this is now minus 0.5, and this is what? 0.5. So any value between 0 and 0.5, we usually say that we have weak positive correlation. Any value above 0.5 to 1, we usually say it is what? Relatively strong positive what? Covariance. The same applies to the negative side, where we said that is any value between 0 and negative 5. We usually say this is what? This is a weak negative correlation. Okay. And these we usually say now this is what? Relative from that is from negative 0.5 to negative 1. We usually now say this is a relatively strong negative correlation. Okay. So correlation ranges from negative 1 to 1. And then in case we get a correlation of 0, then it means we don't have any relationship, okay, between what? Between the two variables. Let's assume variable x and y. Then it means we have no relationship. Let me give you that is an example. Like your salary. Let's say salary is majorly affected by what? By experience. Okay. Salary is always affected by what? By experience. So there exists a relationship. Okay. There exists a relationship between salary and what? Experience. Now the strength, the strength of the relationship, we can always now compute using what? Correlation. Okay. Like for example, if we create a model, a predictive model, to that is to determine determine the correlation. Okay. We will always get what? But this majorly we'll discuss it when we will be that is when we'll be dealing with linear regression. When we'll be dealing with the linear regression, it's when we'll talk in depth about correlation coefficient and also coefficient of determination. Okay, that is the goodness of it, and we shall see the difference. Okay, so what I was trying to mean, there exists a relationship between salary and what? There exists a relationship between salary and the experience. Okay, of course, we know that the higher the experience, of course, it will impact your that is your salary in a positive way. Okay, meaning your salary will increase. Okay, so correlation coefficient is a statistical measure of the strength of the relationship between the relative movement of two variables. The values range between negative 1.0 and 1. A calculated number greater than 1 or less than negative 1.0, then it means there was error when calculating what? Your correlation. So, a correlation of negative 1 shows we have a perfect negative correlation, while a correlation of 1 shows a perfect positive correlation. And a correlation of 0 shows no linear relationship between the what? Between the two variables, as I had illustrated in what? Under this number line. If you understand this number line, then you will be good to go on correlation topic. Okay, yes. So correlation statistic can be used in finance and what? In investment. Like for example, a correlation coefficient could be calculated to determine the level of correlation between the price of crude oil and the stock price of oil producing what? Company, such as maybe this company. Like for example, if the price of the oil, okay, if the price of the crude oil increases, definitely so does the shares. Okay, if that is in most cases, if the what? If the oil company, that is the prices of oil increases, okay, then definitely its shares will be what? Will be impacted in a positive way. Okay, so since oil companies earn greater profits as oil prices rises, then the correlation between the two variables is very high. That is the price of the price of oil, and also the price of what? Oil producing what? That is the prices of shares in an oil producing company. So at least there we can see we have what? We have a positive that is correlation. Okay. Um, Before we can go to the takeaways, let me that is go through another that is slides. Okay, so understanding the correlation coefficient. So we have several types of correlation coefficients, but the one that is most common, it's the Pearson correlation. I think we've those who have done statistics have ever calculated what? The Pearson correlation. Yeah, and this measures the strength and the direction of the linear relationship between two variables. It cannot capture nonlinear relationship between two variables and cannot differentiate between the dependent and independent variables. We'll talk about these dependent and independent variables when we'll be talking about what? Linear, that is a linear regression. Okay, that is, we'll come up with such a model. Like this, you can see this is the what? A model. which assumes the equation of straight line. You can see itself, it is a model. We have the dependent variable because it depends on these values. Okay. Then we have x, which is the independent variable. Okay. Independent variable. And we usually call them the inputs. And these are the outputs. Then we have these two constants, a and b, whereby it is the what? Constant attached to x variable. Okay. Or it is the slope. We also call it the slope or the granted. Okay. Or we can say change in y over change in x. Okay, and then we have b. B, which is what? It is the y-intercept. It is the y-intercept. I shall illustrate this when we'll be dealing with linear regression. And that linear regression is the next topic which we will enter next week. Okay. Yeah, so next week, Tuesday, we will be starting on linear regression after we've covered the practicals for the previous what? For the previous presentations. Okay, good. Then a value of exactly 1 means that there exists a perfect positive relationship between the two variables. For a positive increase in one variable, there will be also a positive increase in the second variable with the same degree. If I was to add, because the change will be what? Will be, that is the magnitude of change will be will be constant. So a value of negative 1.0 means there is a perfect negative relationship between the two variables. This shows that the variables move in opposite direction. Okay, this means that the that is um, this means this shows that the variables move in the same direction. For a positive increase in one variable, there is a decrease in the second variable. Like if we have an increase in one variable, it will lead to a decrease in what? In the other variable. So if the correlation also between the two variables is 0, then there exists no linear relationship between what? Between these two variables. But these I've already explained. It is basically to make you maybe understand more. So the strength of the relationship varies in degree based on the what? On the correlation coefficient. Basically, this is the summary of all what I had discussed under what? Under the number line. That is values between 0 and 0 point what? And 0 0.5, and values between 0 0.5 and what? And 1. Okay. So for example, a value of 0.2 shows there is a positive relationship between the two variables, but it is a weak correlation, which is likely unimportant because we can even conclude that we have very minimal or we have a very small relationship between what? Between the two variables. And most of the analysts, they usually consider that is a strong correlation, that is a correlation to be that one which surpasses what? At least 0 point what? At least 0 0.5. Because even 0 0.5, it's like you are in 50-50. Okay, you can be strong, you can be what? You can be weak. Okay, so that is a correlation of 0.8 or a correlation of 80%. It's more that is referred as a strong what? It is mostly preferred as a relative strong correlation. However, we are saying that correlation coefficient with an absolute value of 0.9 or greater would be represented as a very strong what? As a very strong relationship. Then with that, we have some applications or how we use or how correlation statistics is used in what? In investment. Okay, how it is useful. And as I had said, it will help the investors to gain what? The diversification what? The diversification benefits. That is, the correlation between two variables is particularly helpful when investing in financial markets. Like, for example, if a correlation, for example, a correlation can be helpful in determining how a mutual fund performs relative to what? To its benchmark index. Okay, we usually have some benchmark index whereby it is like an average of what? Of a share price of almost more than what? More than 500 what companies. Okay, that's what we call a benchmark index. Like, for example, we have, I think we have this one for the financial guys. I've ever came across index 500, or I don't know if it is 500 index. Okay, that is meaning it is a share price. Okay, from what? An average share price from almost 500 what big companies. So it is used as a benchmark. So, or other funds or assets class. By adding a low or negative correlated mutual to an existing portfolio, the investor gains the diversification what? By it gains diversification benefits. Okay, like, for example, if you are investing into like that is, or your mutual fund portfolio as I correlation what? That is mutual funds, then it means what? It means also you are at risk. Okay, in case of any one factor bringing that is the prices down, then it will impact you. Okay, but if maybe your investment, okay, investments have that is have an, or they are negatively correlated, then it means you are enjoying the benefit of diversification. Why? Because at least that is all your investments are not affected by the what? By the same factors. So, in other words, we are saying that investors can use negatively correlated asset or security to hedge their portfolios. That is, to reduce market risk due to volatility or world price fluctuations. Many investors hedge the price risk of a portfolio, which effectively reduces any capital gain or reduces the capital that is losses, because they want the dividend income or the yield from the stock or the security. So with this, at least now you don't have that what the greed to gain more. Okay, so you are at equilibrium, you are not losing much, you are also not gaining what? Gaining much. Okay, and with that you will definitely enjoy that is the dividends yield at the end of what? At the end of the year. Then let's go to takeaway. So under takeaway, we have that is called correlation coefficient are used to measure the strength of a relationship between two variables. Also, Pearson, it's one example of correlation, Pearson rank. That is, Pearson correlation is the most commonly used in statistics. This measures the strength and the direction of what? Of a linear relationship between two variables. And also, we have values always range between -1 and 1, as we had said. And then for correlation coefficient values that are less than positive 0.8 or greater than 0.8, they are uh, or greater than, sorry, or greater than negative, there is a negative here, are considered as what? As significant. Yeah. So basically, that's about that is correlation. And then we have a formula for correlation here. Okay, so correlation, we've said that is given by covariance. You can see it is given by covariance divided by the standard deviation of the what? Of the two variables. Okay, you can see we have that is the sigma for x and sigma for y, meaning it's the standard deviation for variable x and variable y. Yeah, so that's all about covariance and correlation. What is remaining? It's now the practical session. Okay, that's what is remaining. Then from next week